मॉर्निंग. हाँ कैसे झाला? Yes, 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 yes. Just a minute. Okay, fine. I hope everybody has gone through the synopsis what was sent in the last class. Yeah? Yes or no? Huh. Okay. Please settle down. Everybody please settle down fast. Okay. So shall we start? Shall we start? Huh. Where are the mics? Please pass the mics to the students. Every coordinator please pass the mic to the students. Okay. So shall we? Okay, so last class we did a couple of problems and I hope that we winded up till this problem as the last ones, if I'm not wrong. This was the last problem what we solved, 2023 based problem, correct? Where I said that this question was wrongly given in KCET and you have to solve it by this particular process and you will get the grace mark, correct? Yes or no? Remember? Remember? Okay. So for today, we are going to solve with Biot-Savart's law. Okay? Yes? Fine? Students, is it fine? Yeah, everybody can see the board? Yes. Okay. Now, what does Biot-Savart's law state? What does Biot-Savart's law state? That is nothing but if at all there is a wire or if there is a conductor in which the current is flowing, then the magnetic field generated by the current carrying conductor can be given by this particular formula, that is mu naught by 4 pi ideal sine theta by r square, correct? Correct? Huh. If say for example we want to go with the vector form of that, vector form will give me that mu naught by 4 pi I into r cross dl divided by r cube, correct? Okay, good, fine. Now, based on this, what did moving charges and magnetism say is, what if the wire becomes a straight line? What if the wire becomes a circle? What if wire becomes a semicircle? What if the wire becomes a pentagon? Then finding out magnetic field on the different shapes of conductor is nothing but called as applications of Biot-Savart's law. Did you understand? Is it clear? So first thing, this is there in your textbook. If at all the wire is an infinitely long straight conducting wire, then if you want to find out a magnetic field at a point P, textbook says that you can find out by using a formula B is equal to mu naught I divided by 4 pi d sine of theta 1 plus sine of theta 2. Is it correct? Correct? Huh. Then what does it say? If the same point, let's say for example, if it is brought at one particular end, then one angle will become as 90 degree, the other angle will become as 0, correct? For a semi-infinite wire, it means that if this point is brought here, then one angle will become 90, other angle will become 0. So the formula will change to mu naught I divided by 2 pi d, correct? Huh. Similarly, one more thing I have not added it here, that is nothing but if at all the point lies exactly on the axis, let's say for example here, or let's say for example here, then the magnetic field will be equal to 0. This you can add up. Did you understand? Understood with this? Yeah. Okay. All the students who have not occupied the front seats, please occupy the front seats. Satish, please make sure that the students are occupying the front seats. New PUC Raibag. Okay. Now, similarly, if at all the conducting wire is a circle, similarly, if the conducting wire is in the form of a circle, and if you want to find out at a particular point, then you have a 5-mark derivation for this. Am I right? In your PU examination. Magnetic field on a circular coil carrying current, or a magnetic field at a point on the axial line lying on the circular coil carrying current, correct? Final result is nothing but this one. B is equal to mu naught I r square divided by 2 times of r square plus x square raised to 3 by 2. Yes, huh. If the same point has been pushed from here to here, that is nothing but from there till the center, then the magnetic field will change to as what? That is nothing but mu naught, sorry, B naught is equal to mu naught I divided by 2R. Did you understand? Huh. If at all instead of one circle, let's say for example there are multiple circles or n turns, then whatever we are going to get on the numerator, we will just multiply it with n. Did you understand? See, I have put multiplied with n here. Similarly, this is the normal formula, I have put n. If at all this is the normal formula I want to find out for n, then I will write it down as B is equal to n times of mu naught times of I divided by 2R. Did you understand with this? Is it clear? Any doubt in this? Okay. Now one more thing I will just add so that it becomes easier for you. One more thing I will just add, it becomes easier. Okay. So let's say, let's put it in this way, because most of the problems will come on this only. Most of the problems will come on this only. Let's say for example this is the circle, and let's say this is the center. So from the center, if I try to draw a line and this distance is x, let's consider that this distance is how much? That is r. This is the radius. Then this point is P. If at all current is moving in this direction, let's say consider this as I and this as I, then we know that B is equal to, it is how much? Mu naught times of I divided by I into R square divided by 4 pi into R square plus X square raised to 3 by 2. Am I right with this? Perfect. Any doubt? Huh. If P comes at the center, that is nothing but if B becomes B naught, if P comes at the center O, then what will happen when B is equal to B naught? X value will become as 0, correct? Huh. That time what will happen? B is equal to, it is mu naught into I R square divided by 4 pi R square plus 0 square raised to 3 by 2. So what will happen? 0 square plus R square will give you as R square raised to 3 by 2 is nothing but R cube. R and R will go. So B is equal to mu naught I divided by, oh sorry, I did a mistake. Sorry, that is not 4 pi, it is 2. Sorry, correct? 2. So this will become as 2R. Am I right? Yes or no? Now the problem is not this. This is all what we have understood. Problem is sometimes they give you something like this. Let's say for example, if this is the current, this is AB conductor and this is the current which is flowing, then what is the magnetic field at O? This is what they give. Do you understand? This kind of problems usually get generated in KCET. Did you understand with this? Okay. Now, how will we find it out? Very simple. How will we find it out? Very simple. For complete circle, how much is the angle covered? For complete circle, 360 degree. 360 degree means it is equal to how much? 2 pi. That time how much is the magnetic field? Correct? Yes or no? So for any other angle, let's say for example, if it is a theta, for any other angle, let's say for example, if it is theta, then how will we find out? Simple method in mathematics what we used, that is unitary method. Do you remember unitary method? For 2 pi radians, the value is B. For theta radians, how much will be the value? Or B naught will be equal to how much? B dash will be equal to how much? So B dash will be equal to, it is nothing but B into theta divided by, simple. I hope it is understood. What is B? B is nothing but mu naught I by 2r. So this will what happens? Mu naught I divided by 2r into theta divided by 2 pi. Now tell me, using this formula, can you tell me what is the angle here? Semicircle means 180. 180 means how much? Pi. Can I put pi here? When I put pi, pi and pi gets cancelled. 1 by 2 remains. 2 will multiply with this. This will become as mu naught times of I divided by 4r. Correct? Yes or no? So it means for semicircle, this is the formula. If you check back in synopsis, there was one sentence given, that is magnetic field generated by a semicircle is equal to mu naught I divided by 4 times of r. Did you understand this? Now for any numerical, this is the shortcut formula. For any numerical, it is a shortcut formula. Understood? So whichever numerical comes based on the semicircle kind of thing, apply that formula, get the answer. Is it clear? Now let us see. Now let us see some question. Okay. Now what is given here? What is given here? The magnetic induction at center O in the figure shown is, let's consider that this is the center O. Let's consider that this is the center O. Magnetic field induction at the center O in the given figure can be calculated by what formula? Okay. Now how will I do? How will I do? Shall I divide this diagram into different things, that is A, B, C, D? Shall I put it in this way? Total magnetic field at O is equal to magnetic field generated by AB plus magnetic field generated by BC plus magnetic field generated by it is CD plus magnetic field generated by it is DA. Perfect? Perfect? Yes or no? Yes, AB. This is the what wire, and this point lies on the same line. So what did I say in synopsis? What should be the value? Magnetic field is 0. Same wire, it is on the same line, axial line, magnetic field is 0. So can I say that this value is equal to 0? Perfect. Okay. Is there any other value which can be given as 0? Okay. Magnetic field at CD is also equal to 0. Perfect. What is left out? BC and DA. Okay. Right hand clasp rule, let me apply. What is right hand clasp rule? If say for example, thumb represents the direction of the fingers, thumb represents the direction of the current, the rest of the fingers will explain you the direction of what? Magnetic field. Am I right? So let's apply it for BC. BC, what happens? Direction of the current is like this, magnetic field is outside. Perfect. Now this current is like this, magnetic field is inside. So it means that one magnetic field BC is generating outside, one magnetic field is going inside. So can I say that net magnetic field B naught is equal to, it is magnetic field generated by AD minus magnetic field generated by BC? Yes or no? BDA minus BBC. Correct. Okay. Is this a semicircle? Is this a semicircle? Do we know the formula for the upper semicircle? Do we know the formula for lower semicircle? Put the formula and tell me what should be the answer through cue card. Put the formula and tell me what should be the answer. What should be the answer? Fast, fast, fast. Easy, right? Here only I have given semicircle formula is mu naught I divided by 4r. If I want to apply it for which one? AD, then R is R2. If I want to apply it for BC, then R is R1. So once I have to apply for R2, once I have to apply for R1 in place of AD and in place of BC. And tell me what is the formula? Which one? Huh? Option B. Hey, how come option B, man? Option C. How come? How come option C? Option A. Option C, how will the answer be? Simple, right? See, here it is given. BDC, sorry, BAD. BAD will be equal to mu naught times of I divided by 4 times of, it is R2. And then BC is equal to, it is mu naught times of I divided by 4 times of R1. Replace and put it into this formula. What do you get? How do you get magnetic field directly proportional to distance? Magnetic field is never directly proportional to distance, correct? Huh? That is fine. You got 1 by R2 minus 1 by R1. Good. This question has to come. This question has to come. Did everybody get this? Perfect. Okay. Now, I don't know whether you people have understood this or not. Okay, but small thing, I did a small intentional mistake here. I did a small intentional mistake here. Okay, that is nothing but, I'll show it to you. Wait. Okay, I can't rub this. Just a minute. I'm so sorry. Okay. Okay. Small intentional mistake I did here. Okay. Actually, I wrote down the formula as B naught is equal to BAD minus BBC. Actually, the formula should be B naught is equal to BBC minus BDA. How many of you noticed this? Why should not the formula be like this? Why should it be formula like this? Anybody noticed? Shall I tell you? I want to find out magnetic field at O due to this wire and due to this wire. Which wire will have strong magnetic field at O? The wire which is nearby will have more magnetic field. The wire which is far away will generate less magnetic field. Am I right? So what should happen? Magnetic field of BC will be stronger. Magnetic field of AD will be lesser. So net magnetic field will be stronger minus lesser. Am I right? So I wrote it here as BAD minus BBC just to confuse you. Now actually it should be the other way around. Now do you get the option A to be as right answer? Yes or no? Yes? Okay. See, let's see with the answer. Is it correct? Yes, sir. Understood? Okay. Anybody has any doubt? Anybody has any doubt? No, sir. Okay. Perfect. Can we go with the next one? Can we? Okay. Okay. Fine. Fine. Let's see this. What is given? A battery is connected between 2 points A and B on circumference of a uniform conducting ring, okay, of radius r and a resistance capital R. One of the arcs AB of the ring subtends an angle theta at the center. The value of magnetic induction at the center due to the current in the ring is, okay. Now, such kind of questions how to approach. Such kind of questions how to approach. The first thing is, the first thing is, what are you supposed to do is nothing but you are supposed to finish the diagram of this. Is it clear? Now how to draw a diagram? Let's see here. Let's see here. What is given? A battery is connected between 2 points of A and B on a circumference of a uniform conducting ring. Okay, let's consider that like this. There is a ring. There are 2 points. Let us consider this as 1 point. Okay, and let us consider that this as another point. Okay, this is connected to a battery. Now they are saying that this point is A, this point is B. Okay, let's consider this as the center. So this is center, which is subtending an angle called as theta. Is it correct? Is it correct? Okay. If this is theta, what is the rest of the angle? What is the rest of the angle? 2 pi minus theta. Perfect? Okay. Say for example, from Kirchhoff's law we have understood if the current goes like this, current goes like this, current goes like this, then when it comes here the current gets divided into 2 parts. Correct? Not 3 parts. This is radius. 2 parts. Correct? Yes or no? The current goes like this and it comes back here. Correct? Am I right? So it means that one magnetic field is generated by bigger arc, another magnetic field is generated by smaller arc. Am I right? How to find out? Okay, this is the direction of the current. Put it here. The magnetic field is coming outside. So this one will have a magnetic field outside. Sorry. This one will have a magnetic field outside. And this one, the magnetic field will be inside. Correct? Yes or no? Are you understanding this? Everybody understood this? Huh. Net magnetic field will be equal to what? As both of them are at the same point, the larger magnetic field minus the lower magnetic field. Correct? Yes or no? Huh. Now what you need to do? Once you have to apply it for theta, once you have to apply it for 2 pi minus theta. Can we solve this? Can we solve this? And this has been intentionally put. This has been intentionally put. I'll tell you how to do. This is one. There are 2 points. I'll take it like this. This is battery. This is point A. This is point B. It is subtending an angle called as theta over here. So remaining angle is nothing but it is 2 pi minus theta. One current is flowing in this direction, one current is flowing in this direction. Now this is creating a magnetic field, this is creating a magnetic field. Now we know that magnetic field to be generated by an arc can be given by a formula mu naught I divided by 2 times of r into theta divided by 2 pi. Is it right? So if I apply it for smaller arc, small ab, then formula will be B is equal to, it is nothing but, I'll write it down as B small, okay? Bs is equal to, what will happen? Mu naught times of I divided by 2 times of r, then theta divided by 2 pi. If say for example I want to apply it for larger arc, if at all I want to apply it for larger AB, then B of large will be equal to mu naught times of I divided by 2r into what? 2 pi minus theta divided by 2 pi. Is it correct? Both of them, distance of this wire to the point center, distance of this wire to the point center is same. Yes or no? This is also a part of a circle, so center distance is same. This is of a part of a circle, center's distance is same, correct? Then it means that which one, AB bigger or AB smaller, will produce more magnetic field? Which one will produce more magnetic field? Which one will produce more magnetic field? Larger one will produce more magnetic field because more current is flowing, more length it is flowing, so it will produce more magnetic field. Less length it is flowing, so it is producing less magnetic field. So net magnetic field B naught, can I say that it is nothing but BL minus B? Yes? Now put the value. What do you have? Mu naught I divided by 2r is common in both. Even 2 pi is also common in both. Correct? Remaining is nothing but 2 pi minus theta, then minus theta. Am I right? Yes or no? Yes, so what will happen? This will become as 2 pi minus 2 theta. Correct? So what will happen? Can I do like this? B naught is equal to mu naught I divided by, it is nothing but 4 pi r. In numerator, can I take 2 common and make this as pi minus theta? 2 gone, 2 2s are gone, left out is nothing but what? Mu naught times of I pi minus theta divided by, it is 2 times of pi into r. Correct? Perfect? Now let's see. Now come back. See, proportional to 2 times of pi minus theta. Is it correct? Proportional to 2 times of pi minus theta. Is it correct? Yes. Or is it proportional to pi minus theta? It is proportional to pi minus theta. Yes or no? Are you understanding the question? Anybody has a doubt? Please raise your hands. Yeah. Somebody had a doubt. Is there a doubt? So in the final answer we have seen that B is proportional to pi minus theta. B is not proportional to 2 pi minus theta. Is it correct? Huh. So it means that this is wrong. Sorry. This is wrong. Is it inversely proportional to R? Is it inversely proportional to R? Yes. So it means that this is the correct ones. Correct? Okay. 0 only if theta is equal to 180. So if I put theta is equal to 180, pi minus pi will become as 0. Pi minus pi is equal to 0, so it means B naught is equal to 0. Is it right? Correct. So it means that this is also right. Okay. And what about 0 for all values of theta? So if I put any different value of theta also, it will be 0. Is it correct? No, right? If I put theta as pi by 4, will it come as 0? No. Okay. So now in this question, what has happened? Tell me. In this question, what has happened? Tell me. Two correct answers have come. Does KCET offer two correct answers? KCET says that there is only one correct answer. Am I right? But there are chances that in IIT, right, in JEE, there is an examinations where more than one correct answer also might be correct. I mean, more than one options also might have a correct answer, correct? From somewhere when this particular question or the type of the question is been borrowed in KCET, nobody has given the intention or nobody has given that courtesy of seeing that whether two answers will become correct or not. So this question turned out to be as a grace problem. Did you understand now? Is it understood? Okay. So if I see with the solutions, you can see here, two of them have the same correct answer. Okay. But the thing is, only one can be the correct answer, because of which this particular question should be given as a grace. Okay. Now grace is defined in a different term, saying that one who have answered between B and C, only them they have given as the marks. Rest of them they have not given. This might also be a problem. Or otherwise, anybody who has attempted with any of the options, them also they have given the marks. Did you understand with this? Okay, it depends upon the board how they calculate. Clear? Good. Okay, fine. Can we go with the next one? Okay. Can you find out this? This I will not help you. Can you find out this? Can you find out this? The magnetic field at the center O of the given figure is, you have to find out the magnetic field here by this particular part, where this angle is given as 60. Can you calculate? Formula is this one. Yes? Yes or no? Now can you calculate and tell me? How much should be the theta value? How much should be the theta value? Huh? Theta is equal to, don't tell me 60. 2 pi minus 60 can be given in terms of pi. Pi by? So how much will the value be? 3 to the 6, 6 pi minus 1 is nothing but 5 pi by 3. Correct? So this angle is 5 pi by 3. Answer through cue card and tell me how much is the answer at magnetic field at the center. If this angle is equal to 5 pi by 3, what should be the value? Option D. Let's see. If at all I put it as 5 pi by 3, pi and pi value will get cancelled. 3 to the 6, so 5 by 6. 5 by 6 mu naught I divided by 2r, 6 to the 12, mu naught 5 mu naught I divided by 12r will be the answer. 5 mu naught I divided by 12r is the answer. Option D is the right answer? Yes, sir. Yes, everybody says option D? Yes, sir. Okay, let's check if the answer is correct. Option D is the correct answer. Did you understand now? Yes, sir. Anybody has any doubt? No, sir. Perfectly understood? Yes, sir. Perfect. Okay, fine. Let's try with the next one. Okay, this is a direct question. How can a Biot-Savart's law can be given, sir, not Biot-Savart's law. How can magnetic field to a conductor can be given in vector form? What is that? This is 27th slide. 27th slide. How can it be given in vector form? Hmm. So is it there in the option? Is it there in the option? Option? One more time, one more time, one more time. Option C, right? You said one more time. We will see. One more time. Properly say what is given. Is it R cross DL or DL cross R? And R cross DL should come, and at the bottom what it should come? Now go back. Option D. Yes, because here it is DL cross R. A cross B is never equal to B cross A. Remember this. Okay? Always remember this. A cross B is never equal to B cross A. It is not a cross, doesn't mean that it is a multiplication in mathematics. A into B is equal to B into A, you have an associative property. But when it comes to vectors, A cross B is not equal to B cross A. Did you understand with this? So which will be the option correct? Option D. Let's see if the option D is right. Yes, option D is right. Do you understand now? Okay, fine. Let's go with the next question. Okay, now try to find out. In the given figure, the magnetic field at the center O is equal to. Can you tell me what is magnetic field at the center O? B naught, can I write it down as? No. Gone, wrong. First tell me B naught, total magnetic field at the center, is associated with how many elements? 3 elements. Very good. Now you are coming right. One is magnetic field due to AC plus magnetic field due to CD plus magnetic field due to DE. Correct? Yes or no? For magnetic field due to AC, how much is the magnetic field? Very good. This you have understood. Okay. Magnetic field, one angle is 0, one angle is how much? 90. Do you remember this? I told you. Yes or no? Here. This is 29th. Here. What did I tell you? If, say, for example, 1 point lies here, that is nothing but for a semi-infinite wire with a semi-infinite wire, that is nothing but if the point lies here or if the point lies here, one angle will become 0, the other angle will become 180, correct? Yes or no? Not 180, it should be 90. 90, it should be 90. By mistake I have written it as 180, correct? Yes or no? That time what will happen? One angle is 0, it will go off. One angle is 90, sin 90 will become 1. 1 you will multiply with here, you will get it as mu naught I divided by 2 pi d. Did you understand with this? Now if, say, for example, I apply that, I can apply it for this one. BD, correct? Yes or no? Perfect. Did you understand this? And then for this semicircle, how much is the angle? 2 pi minus 90. So can I write it down as how much? 2 pi minus 90, that is 270 degree. 270 degree can be written as what? 3 pi by, yeah, correct. 3 pi by 2. Am I right? Yes or no? For this, what formula will you apply? B is equal to, B naught is equal to B into theta divided by. Perfect. Now apply this. What will you get? Now apply this. What will you get? What will you get? 1 is 0. This will become 0. Plus this will become as mu naught I divided by 2 times of r, and then multiplied by with theta is 3 pi by 2. 3 pi by 2 divided by 2 pi will give you as 3 by 4, correct? Yes or no? Okay. Plus this will give you how much? One angle is 0, one angle is 90. So mu naught I divided by 4 pi d, angle is 0 and 90. 0 means this will become go, and this will become 90 as 1. So mu naught I by 4 pi d. Mu naught I divided by 4 pi r, correct? Yes or no? Huh. So which is that option, right? 3 by 8 mu naught I, 3 by 8 mu naught I by 8 are correct, and option A should be the right answer. Let's check. Let's check. Option B they are saying. We did a mistake here. Correct. What is that? This current is going like this, so the magnetic field is inside. This current is going like this, so the magnetic field is outside. Correct? So what should happen? It shouldn't be addition, it should be subtraction. Correct? Yes or no? Understanding? One magnetic field is there, it is going inside. One magnetic field is there, the magnetic field is coming outside, correct? If you take the direction of the current like this, what is the magnetic field? It is outside. If you take the direction of the current like this, what is the magnetic field? It is inside, correct? Yes or no? Yes, then the net magnetic field will be addition or subtraction? Subtraction. So the correct answer should be, sorry, correct answer should be, this one should be removed, and answer will be this one. Am I right? So the answer is here. Clear? Okay, fine. Can we go with the next one? Okay. Try with this problem. Try with this problem. This is a direct question. You can solve it using cue card. Try with this problem. A circular coil of wire of radius r has n turns and carries current I. The magnetic induction B at a point on the axis of the coil at a distance root 3r from its center is. So magnetic field at a point on the axis of the circular loop can be given by this particular formula, where n stands for number of turns. Now what he is saying is nothing but it is on the axis with a distance root 3. It means that this x value is equal to root 3. Can you put x value is equal to root 3 and find out what is B value? Simple it is. Put x is equal to root 3 and find out what is the B value. Can you tell me? Can you tell me what should be the answer? Fast, fast, fast. If you put root 3 there, root 3 square will give you as 3r square. 3r square plus r square will give you as 4r square. 4r squared raised to 3 by 2 means 4r square first should be what? It should be reduced to root value. So 4r square root is nothing but 2r. 2r the whole cube will be the denominator. Now 2r the whole cube, if it is in the denominator, what will happen is nothing but r square is on the top. So r square and 1 r cube in the bottom will get cancelled. So remaining will be only r. 2 cube is nothing but 8, 8 2 is nothing but 16. So you will get 16r in the denominator. Do you have anything in 16r? You should answer this fast, no? You should answer this fast. Is it right? Did you understand this? Yes, yeah? Or do you want me to explain this? See, people find it difficult here. People find it difficult here. People find it difficult here. That is nothing but r square plus x square raised to 3 by 2. How to solve this? Now, can I write down this one as r square plus x square raised to half whole raised to cube? Can I write down like this? Yes or no? What is half? Half is nothing but root of r square plus x square, then whole cube, correct? Now put the x value. X value how much they have given? Root 3. Now put, what will you get? Root of r square plus root 3r the whole square whole raised to cube. Correct? Correct? Root 3r the whole square is nothing but 3r square. 3r square plus r square will give you how much? 4r square. Again this is cube. Okay, 4r square root is how much? 2r. Yes or no? Root of 4r square is nothing but 2r. This is cubed. So it is nothing but equal to how much? 8r cube. Am I right? That 8r cube you put it here. What will happen? B is equal to, it is mu naught times of n I r square divided by 2 into, you have got this as 8r cube. Correct? So r square and in 3, 2r have gone. So what is left out? It is nothing but mu naught n I divided by 8 into 2 is 16. Only one r is left. That is nothing but r. Correct? Yes. So the answer is mu naught ni divided by 16r. Is it clear? Okay. Fine. Okay. Answer is correct. Okay. Can we go with this one? A proton and an alpha particle. First tell me what is alpha particle. First tell me what is alpha particle. Alpha particle means what? Hey, tell me fast. What is alpha particle? Just be loud. It is correct. He plus. That is nothing but what? It is helium atom. Correct? Helium atom has how many protons and how many neutrons? 2 protons, 2 neutrons. Am I right? So mass of an alpha particle will be equal to 4 times the mass of protons. Correct? Because 2 protons and 2 neutrons. But charge value of alpha particle will be only equal to 2 times of charge of proton. Why? Because neutron do not have charge at all. Correct? The same thing I have written. Mass of alpha particle is 4 times of mass of proton. Charge of alpha particle is nothing but 2 times of charge of proton. Whereas if you talk about only proton, proton is mass of proton as well as charge of proton. Is it correct? Now what they have asked is nothing but the ratio of the radii in the circular path. How do you find out radii? R is equal to mv upon qb. Between proton and alpha particle. So if I apply it for proton, what will happen? R of proton will be equal to mass of proton, velocity divided by charge of proton into magnetic field B. If I apply it for alpha particle, it will be nothing but 4 times of mass of proton into velocity divided by 2 times of charge of proton into B. Correct? Now tell me what is Rp divided by R alpha. They are asking me Rp divided by R alpha is equal to how much? Tell me. What will happen? 1 by? 1 by 2 is nothing but what? That is Rp is to R alpha is equal to, it should be 1 is to 2. Which is the correct answer? Option D is the correct answer. Did you understand now? Let's see. D is the correct answer. Got it? Okay. Shall we solve one more? Okay. This is the synopsis actually. Just a minute. I'll go back with this. So right now this is one formula what you have to understand. This is the last phase of this chapter. You know about this formula? 2 parallel conductors. This is again a 5-mark derivation. Force between 2 charged conductors, if they are moving in the straight line or in the same direction, then it can be given as mu naught times of I1 I2 dl divided by 2 pi d. Correct? If it is in the same direction, then it is attractive. If it is going in the opposite direction, then it is repulsive. Good. Fine. Current sensitivity, moving coil galvanometer. This formula is also there. That is nothing but if at all you connect a very small and negligible resistance in parallel with that of a galvanometer, which we call it as a shunt resistance, then the complete setup will change to as an ammeter. Is it right? If there is a very high resistance which is connected in series with that of a galvanometer, then we call it as a voltmeter. We know that that resistance what we call here is nothing but called as shunt resistance. Just for a information, I am telling you that that resistance which is connected in series to make it as a voltmeter, that is called as ballast resistance. Please note down this. It is not there in your textbook or it is not there in your NCRT. Okay, but we don't know that KCT might come up with something else and they might give you this word called as ballast resistance. Ballast resistance is nothing but that very high resistance which is connected in series with that of the galvanometer to convert the galvanometer into a voltmeter. Did you understand with this now? Okay. Formulas are also the same. Shunt resistance can be given by Ig divided by I minus Ig into G. Here also resistance can be given by V divided by Ig minus G into G. Correct? Okay. Okay. Can we solve this based on this? What is the value of shunt resistance required to convert the galvanometer into resistance of 100 ohms, okay, of an ammeter of range 1 amp, given full scale deflection of the galvanometer is equal to 5 milliamp. So it means that I value is given to you, that is nothing but how much? It is galvanometer to be converted of an ammeter of range 1 amp. So this is 1 amp, this is 5 milliamp. Galvanometer resistance they have given it as, how much they have given? 100 ohms, okay, and they have asked what is shunt resistance. Can you calculate? Can you calculate using this formula? What will happen? 5 into 10 to the power of minus 3 divided by, it is 1 minus 0.123 and into G, it is nothing but 100. This is also becomes as 1.005 divided by 1 minus this will give you as 0.995, correct? Yes or no? Into 100. So this is as good as you will get it as 100 into this will give you as 0.5. 0.5 divided by 0.995. So if I at all for calculation purpose I take this to be as, okay, they have given it ratio only, fine, very good. So I can shift this point, so this will become as 5 divided by 9.95. Do you have an answer? Option B. Correct? Yes? Understood this? Let's see if the answer is correct. Correct. Did you understand now? Yes. Okay, fine. So we'll meet up in the next class. Okay, we'll start with a different chapter. There are certain set of assignment questions what I have given over here. I want you people to solve these assignment questions. Is it clear? Okay, this is the maximum set of questions which has come in the last years. Apart from this, I have placed the assignment questions which are in between of 2015 to 2019. The reason why I have placed this as assignment questions is nothing but in these questions there are certain areas which has been rationalized in your syllabus. It is not there in your syllabus. Whichever is concerned to your syllabus, please solve that. That is more than enough. Is it clear?
Yes, sir.
Fine. Okay. Any doubts till now?
No, sir.
Okay. Please do give the feedback after the class. Okay.
Yes, sir.
Okay. Okay. Fine. Yeah.
Bye, sir.
Yeah.